Okay, today we're looking at the bisectors of triangles. We're going to look at angle bisectors in a triangle and perpendicular bisectors of the sides of a triangle. We did a little activity in class where we drew the where is that? We created a triangle. We had read this word problem. She wants to open a soft drink stand. She looks at the map and decides the three most popular rides are the roller coaster, which is right over here, the swings, and the bumper cars. So what we did was we drew a triangle, and I'm sorry, I'm trying to look at my shapes here to see if I can do that. No, I can't find that, but anyways, we drew a triangle from the swings to the bumper cars and the roller coaster. Next, we found the perpendicular bisectors, which we used a compass to do so. And for the sake of this problem, we'll just roughly estimate where that perpendicular bisector would be for each of these. Again, we used a compass in class, but I don't have a tool that will let me use a compass in here, so we'll do this. Perpendicular bisectors splits those segments into two congruent parts, and the point, the word problem says, is it where all of those perpendicular bisectors meet? Is that a good place for her soft drink stand? Well, it's in the middle of the lake, so probably not a good idea, but the reason we use perpendicular bisectors to find this point is this is called the circumcenter, and when we draw perpendicular bisectors, it creates the point that is the same distance from all three corners of the triangle, which we'll go ahead and start talking, which it's called the intersection point is the circumcenter. Okay, and so here we have the circumcenter of these different triangles, and what the circumcenter is, the circumcenter is the center of the circle, and if we were to draw a circle around this, it would include all the sides, all the corners of our triangle. Center of the triangle circumcircle, which is the circle that passes through all three of the triangle's vertices. Notice that one is inside of the triangle. Look at this one. It is on one of the edges of the triangle. But again, it would still be the center of the circle. I apologize for my poor circle drawings, but I don't have a tool in this app that will let me do that. And notice this one has a circumcenter outside of the triangle, which is going to be a large circle, but it's still going to be around all three of those corners. Note right here, it says, notice the circumcenter may lie outside of the triangle. It may lie on it, and it can lie inside of the triangle as well. So, the perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant, which means the same distance, from the endpoints of the segment. Sorry, just getting sloppy there. And what that means is if I have a segment and a perpendicular bisector, then the distance, and I have a point on the perpendicular bisector, then that point is the same distance to the endpoints, to either of the endpoints, making this segment and this segment congruent. That's what the perpendicular bisector theorem says. Now the circumcenter theorem says the perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. Basically, that is what we just talked about, this section up here. That the circumcenter is the same distance. And the reason it's the same distance, if you'll notice, all these red lines that I drew right here in this circle, these are all the radius. They're all radii. It's a radius of that circle. So we know that the radius of a circle is always going to be equal to the radius. So like we have right here, circumcenter. That's why she, in the word problem before, she chose to use the circumcenter to find where the best place for her soft drink stand would be, so that it was the same distance from all three of the popular attractions. Okay, now we're going to look at the in-center. The in-center is the point where now the angle bisectors, different than perpendicular bisectors. So we draw the angle bisectors, and where they intersect is the in-center. The in-center is the center of the circle that contains the in-circle. Okay, in-center is the center of the in-circle. Notice the in-center is always going to be inside of the circle. Okay, and the angle bisector theorem states that if a point is on the bisector of an angle, then it is equally distant from the sides of the triangle or of the angle. And what this is saying is if I have an angle and I draw an angle bisector, meaning this angle is congruent to this angle, and I then have a point on the angle bisector, well, that means this distance from the point, which we'll call this point P, the distance from point P to the end or the sides of the angle is equal. That means those two segments are congruent. Which leads us to a couple of the problems, but before we look at a couple of the problems from using this information, we have one more thing to talk about. If angles are bisected, then the sides are equidistant. If sides are bisected, then angles are equidistant. That's when we're talking about the circumcenter. So let's look at this. Find QS, segment QS right here. QS is this segment right here. Now notice it says that this angle is congruent to this angle, which means it's an angle bisector. So point S is equidistant or has the same distance from the edge of the angle. That means these two segments are congruent. So to find QS, we set 4x minus 1 equal to 3x plus 2. Subtract 3x and add 1, and we get x equals 3. It's not my answer. We now have to take that and plug it into QS, which would make it 4 times 3 minus 1. Well, 12 minus 1 equals 11. That would be my answer. That's the length of QS. Now look at this one. It says to find WYZ. That's this angle right here. Well, if this is an angle bisector, by this I mean YW, if that's an angle bisector, then it would also be 28. But how do we know it's an angle bisector? Well, the fact that this is the same distance from the side tells me it's an angle bisector. Therefore, that is 28 degrees. Okay? Easy one there, not having to work a whole lot of math on that one. And this problem right here. We have the circumcenter, which is formed by perpendicular bisectors, which means each of these segments is perpendicular to a side of the triangle. And also, it makes these congruent. And it says find R if AN, and we're going to have to draw a new segment for AN, is 4R minus 8, and AM, which is 3 times 2R minus 11. Well, the fact that we all agree that point A is on the perpendicular bisector AP, which means the distance from A to the endpoints of the segment being bisected is congruent. So in order to solve this, we set 4R minus 8 equal to 3 times 2R minus 11, and then solve for R. Subtract 4R. And we get R equals 12.5, or 25 over 2. It said to find R. We found R, so we're finished. Okay, let's look at a couple problems from your homework. All right, here, let's look at number 1. We're looking for WYZ. And WYZ is right here, this angle right here. Well, notice these two segments are congruent. If they're congruent, that means WY is an angle bisector, meaning this angle is congruent to this angle. So what is WYZ? Well, the measure of WYZ is the same as XYW, which is 23 degrees. It's 23 degrees as well, right here. Okay, and looking at number 2, here we have a different type of problem. It's a perpendicular bisector, bisecting this segment into 2 equal parts. L, which means if it's a perpendicular bisector, L is the same distance from P as it is from N, which means these two segments are congruent. Solve for that. We say that 10x minus 5 is equal to 7x plus 1. And then we'd solve for x. 3x equals 6, x equals 2. That's not my answer. The answer asks for segment LP, which is 10x minus 5. So we're going to plug in 2 for x. 10 times 2 minus 5, which is 20 minus 5, which tells me that segment LP equals 15, and that's my answer. Okay, hopefully this helps you with the assignment. The rest of them probably shouldn't be a problem with these notes.